Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 3 of DevSecOps Zero to Hero series, and in this episode, we will focus on infrastructure as code security. In the first two episodes, we learned about fundamentals of DevSecOps and securing Git. They are very useful videos. In case you did not watch them, I would highly recommend them. After watching today's video, you can go back to the playlist and complete those videos as well. I'll share the link to the playlist in the description. Now, going back to the context, we will focus on Terraform security in today's video. This video has three primary sections. The first one is the common best practices. What are the common best practices that DevSecOps engineers follow? Then we will learn about a very interesting utility called Checkov. So we will learn how to identify insecure Terraform files using Checkov or insecure Terraform configuration. And finally, we will learn about HashiCorp Vault. So we will learn what is Vault and how Vault is the best companion for Terraform. Basically, we will learn secret management with Vault. Now you don't have to get overwhelmed. All of these concepts we will learn with demos, and the detailed documentation for the demos is already in our GitHub repository. So just like every video, I've created GitHub documentation. So head to our DevSecOps Zero to Hero repo and go to Day-3 folder. Here you can find the checkout.md and wall.md. So this is for the insecure Terraform configuration demo. Again, so I have provided an insecure Terraform configuration. You can use this and you can scan the configuration using Checkov. And then I have the wall.md. This is where a lot of people get confused because to install Vault, to configure it, there are a lot of steps. So I made it simple. All the steps are documented in the order. And to make our demo interesting, I made it real time. So instead of directly using Vault with Terraform, we will also use GitHub Actions. So basically, we will learn Terraform in the CI/CD pipeline, how Terraform is used with GitHub Actions, and how dynamically AWS credentials for Terraform are fetched using Vault. This is what we are going to cover in today's video. So please try to watch it till the end, and after watching, spend 15 more minutes to complete the demo. Perfect. Let's start with common best practices. Now this is very simple if you followed our previous episode, because we covered common DevSecOps practices in the previous episode. Anyways, so basically when you are working with Terraform, let's say you are a DevOps engineer, your requirement is to create an S3 bucket on AWS, or you have to create 2 to 3 resources on AWS. Now, the common things that you have to follow, number one, because you are creating resources on AWS or any other cloud platform, you should not hard code the credentials. Now, this is a very simple one. To eliminate this, we learned in the previous episode, what you need to do, you should create a .gitignore file, and within the .gitignore file, you have to store your .env. I mean, you have to make an entry for .env in the .gitignore. Because you are working with Terraform, you also have to make an entry of your Terraform state file. And then you commit the .gitignore to the Git repository, so that even your colleagues or anyone else who is working in the organization, they also have a reference of your .gitignore. This is a very simple practice. So create a .gitignore file, add an entry for .env if you are using one, add an entry for Terraform state and anything like your PEM files that you are using, IDRSA or sensitive information. This way, you will not even accidentally push your hard-coded credentials or sensitive information. Now, there is a chance, of course, we are all humans. Accidentally, you might miss adding a file entry to the .gitignore file. Now, how to ensure that? You might be a good DevOps engineer, but your colleague might be a junior DevOps engineer. They might not add .gitignore to their local machine. So this is where we learned about pre-commit hooks. So even while working with Terraform repositories, it is recommended to use pre-commit hook so that pre-commit hook will validate your commit. Whenever you run git commit, even before you run git push, you run git commit. So when you run git commit, pre-commit hook is executed and it validates, it verifies if any sensitive information is being stored to your local Git before pushing to the public Git. So what will you have in the pre-commit hook? I have recommended in the previous video to go with Git leaks. Let me show you. If any of you haven't watched the previous demo, or if you have to focus more towards Terraform, we will do a very simple demo how pre-commit hook can prevent accidental pushing of Terraform secrets to public Git. So for that, we will clone our repository, or you can even create a simple folder. But what's important is to use the pre-commit framework. So this is the pre-commit framework. If you want to go through the framework in a very detailed way, the documentation is available. So instead of writing your custom script, you can just install this framework. How do you do that? If you're on Mac, just run brew install pre-commit. If you're on Linux, just run pip install pre-commit. Now, once you do that, within your repository or in a centralized location, you have to create a .precommit file. So .precommit configuration file. And within this configuration file, provide an entry for git leaks. What is git leaks? Git leaks is a utility which will verify any insecure or any credentials that are being pushed. So pre-commit is a framework that is using this utility. We learned a lot about git leaks in the previous lecture, but just to repeat again, git leaks is a simple utility that will run and verify the files that you are pushing to your local Git. And within those files, if there is any password, if there is any secret, or if there is any token, git leaks will instantly block the commit. That's all. This is what you need to do. Add the pre-commit configuration file, and then you need to run pre-commit install. Let's say you already have the repository, then you can run pre-commit auto update. It is better to run pre-commit auto update as well in case you have other pre-commit configuration files. Now let's see the magic. Let's say I will add a secrets.env file, and within the secrets.env file, I pushed my AWS secret access key. Imagine I'm a junior DevOps engineer. I'm working with Terraform. I need AWS credentials, and I created secrets.env looking at some documentation on the internet, or maybe by following ChatGPT. Now, along with other files, I added this secrets.env as well. Now, even if I accidentally push this to the Git, if I don't have this pre-commit framework, and if I accidentally push this to the public Git, it's a major problem for the organization, because once sensitive information is pushed to Git, it's never lost. Once you push your AWS credentials to Git, it's almost never lost, because Git is a version control system. And in big organizations, Git is used by a lot of people. Even if you try to remove using a repo cleaner, or if you try to remove by getting in touch with GitHub support, there is a possibility in this time, by the time you reach the GitHub support, someone might have cloned the repository. Someone might have forked the repository. So during this time, they have a local copy of your AWS secret. So that's why it's considered a very big disaster. Pre-commit hook can help us here. Now that we configured the pre-commit hook, let's see if I run git commit -am. Let's say the junior DevOps engineer is working on advanced Terraform workflow. So junior DevOps engineer runs this commit because pre-commit hook is configured. See what happens. It will instantly block the commit. So it says the secret is redacted. And also it says one leak is found. So I will not let your commit go into the repo. This is a best practice that everyone has to follow. Unfortunately, even after using Git for a lot of years, not a lot of people know about pre-commit hooks, pre-commit framework. Not a lot of people have even heard of Git leaks. So it becomes your responsibility as a DevSecOps engineer to prepare this best practices document and share it within the organization. You cannot go to every person's laptop. You cannot create a .git ignore file. Even you cannot install the pre-commit framework and you cannot install Git leaks. But what you can do, you can set up the best practices document and share it within the organization. Let's say even still someone does not follow. Even after you sharing the document, there will be engineers who will not have time to execute these commands. What can you do? What you can do is very simple. Just go to the Git repository and create a CI/CD pipeline. Something like this. So create a Git leaks workflow and run Git leaks on every commit. And also run it on every pull request. So that even if they store the AWS credentials on their local Git, now when they try to run Git push to create a pull request or maybe to create a commit directly to the branch, the GitHub workflow gets triggered and it will instantly block their commit or it will block their pull request by failing the CI check. So this is the ultimate thing that you can do as a DevSecOps engineer. The CI/CD pipeline configuration is within the same repository. Go to .github, go to workflows, you will find the file. So these are some common best practices that you can follow. Quick revision. What did we learn? We learned about 3 points here. 1, the usage of .git ignore. Every repository in your organization should have a .git ignore file, just like the one that we have here. See how detailed this is .git ignore file. It has all the configuration. So you can find Terraform related ignore files here. You can find Python related ones here. You can find NPM ones related here, whatever your company is using. Then the next thing is to use pre-commit hook. So you should share a document of how to use the pre-commit hook on everyone's local machine. And finally, step 3 is to set up a CI file with the Git leaks. Now, Git leaks is not the only thing. The reason why I have been talking about Git leaks, it's the most easiest one to get started. Otherwise, you have options like Trufflehog and you also have many other utilities. Perfect. So this is about the first section, best practices. Now let's move to the interesting utility, that is Checkov. What is this? Now, a lot of times when people work with Terraform, especially when junior engineers work with Terraform, like everyone, they also use Terraform to create infrastructure. Let's say a simple task is given to a junior DevOps engineer. The task is to create S3 bucket. Now let's say this junior engineer creates the S3 bucket using Terraform takes help of ChatGPT or maybe takes help of internet, Terraform documentation and creates the S3 bucket. This is all good. But what if the S3 bucket is public? Terraform does not warn this engineer. Even the pre-commit hook will not warn the engineer because the Terraform code for S3 bucket is absolutely right. But the problem is that the junior DevOps engineer created a public S3 bucket, and within this public S3 bucket, developers or your existing workflows push some logs and also some sensitive information. Now they thought, other engineers and even your existing systems, they thought your S3 bucket is private, but unfortunately, what the junior DevOps engineer created is a public S3 bucket. How can you prevent this? You might miss this in the code review, obviously, because you cannot go through each Terraform field. On top of that, your CI checks like git leaks or your pre-commit hook is also not catching this. What do we call this? This is called Terraform misconfiguration or insecure Terraform configuration. How do you catch that? Checkov can help you with insecure Terraform configuration. Let's see how it works. So we will first create an insecure Terraform configuration, right? So we will create an S3 bucket like configuration, and within that insecure configuration, on that insecure configuration, we will run the Checkov utility. I'll go back to my terminal. Okay. So I'll create a folder here. Let's call mkdir test. And within this test, let's add a main.tf file. Okay. Let's add insecure Terraform configuration to it. So as we discussed, this is an S3 bucket creation where if you notice carefully, if you worked with Terraform in the past, intentionally, I have disabled blocking of the public ACLs. So block public ACL, false. Block public policy, false. Restrict public buckets also as false. So basically, I'm making this configuration insecure. Now imagine a junior engineer got this code from ChatGPT or somewhere from the internet. What junior DevOps engineer usually does, verifies the syntax using Terraform linting, runs the Terraform plan to see if Terraform creates S3 bucket or not. In this case, Terraform would obviously create the bucket. But what we need is secure configuration or the secure infrastructure. As I told you, this is where Checkov helps. So all that you need to run Checkov -d followed by the folder in which you want to run it. In our case, I want to run it in the same directory where I have main.tf. Now you can see the magic. So Checkov will start understanding your Terraform configuration. It will automatically run checks depending upon your configuration. So it ran 2 + 4, 6 checks. So Checkov initiated. It ran 6 checks, out of which 2 checks are passed and 4 checks are failed. And all these checks are related to S3 bucket configuration. Let's say you run Terraform configuration related to EC2 instance. And if you run Checkov on that, Checkov will run the checks that are only related to EC2 instance. In our case, because we are creating S3 bucket, all the checks are related to the bucket. And this is an automatic process. Okay, let's see which checks passed and which checks failed. So the first 2 checks passed. Basically this one, ensure S3 bucket policy does not lock out all the root user. We did not break that. Ensure S3 bucket does not have global view ACL permissions enabled. Even we did not tweak anything in that. Now see in which cases it failed. Ensure S3 bucket has public ACLs enabled. Yes, we did that. So Checkov says this is a bad security practice. Similarly, ensure S3 bucket has block public policy enabled. Yes, we did that. That's why it failed again. The check. Another check failed and another check also failed. So how is Checkov helping you here? It is helping you as typically like the test cases, but you are not writing the test cases. Lot of times people might also ask you in the interviews, how do you define your Terraform test suite? Apart from your regular tests, you can also talk about Checkov. So you can say, we have integrated Checkov in our configuration. Every engineer runs it locally. Even we integrated this to the CI file. So anyone tries to push a Terraform configuration to our GitHub repo, even there Checkov runs and validates the configuration. Now let's see by fixing it. Okay, we got to know what are the issues. Now let me provide the right configuration in the same file. I'll open the file again, vim main.tf. All that I'll do, I'll change the block permissions or the block features from false to true. Again, the same configuration is provided in the documentation also. You don't have to copy anything from my terminal. Let's save this. So we did not allow, we say block public ACLs true. This means this will block the public ACLs, this will block the public policy, and this will also ignore any public ACLs. Even when we look at the configuration, it feels secure. Let's see what Checkov says. I'll save this and rerun Checkov-d dot. And in this case, all the checks are passed, which is a good case. So ensure bucket has ignore public ACLs, ensure bucket has public policy enabled, ensure bucket has public ACLs enabled. Very nice. So we covered the first two parts. We learned the Terraform best practices from security point of view. And we also learned insecure Terraform configuration verification, that is using Checkov. Now let's head to part 3, that is HashiCorp Vault. Now most of you might have this question. Abhishek, why should I learn something new? Why should I integrate my existing Terraform with a new tool like Vault? Let's start with this. We will understand this through a scenario. Now most of the times when people work on a hobby project, the workflow is simple. So on the local machine, they create some Terraform files. They create a .env file. They create .gitignore, and within the .env, they had the Terraform credentials. Basically, if they are trying to create resources on AWS, they add AWS related credentials to the .env file. Now, after this, they execute Terraform. That is, they execute the Terraform files on the same local machine. Now, obviously, once it's executed on the AWS, the resources are created. This is the usual workflow. Now, if you understand the production workflow, it is totally different. So when you work in the organization, you don't follow this workflow, but what you follow, instead of writing or executing the Terraform files on the local machine, you would execute that through CI/CD or continuous integration. I'll explain the total workflow now. So basically, Terraform files are stored in the Git repository, unlike the local machine. If anyone wants to update the Terraform configuration, they clone the Git repository, they update the changes. Basically, they update the Terraform files. Then they push the changes back to the Git repository. Once they are comfortable, they push the changes. And once the changes are pushed, here CI is executed. Let's say GitHub Actions. And through GitHub Actions, resources are created on the AWS. Now you might ask why? What is the advantage of this approach? There are two major advantages. The first advantage, individually, nobody creates resources on the AWS. Everyone goes through the standard process, that is through CI. So overall, CI is the one that is creating the resources on AWS. Now CI will be provided with credentials, and only through that credentials, the resources are created on AWS. Resources are not created by Abhishek user AWS credentials or XYZ user AWS credentials. Everything will be created using the CI credentials. So there is accountability here. Who is accountable? CI is accountable. On top of that, when you add your Terraform files to Git, just like your application source code files, you get the classic features of Git in place. The first and most important thing, now you can start reviewing the changes. Imagine your team has a junior DevOps engineer and senior DevOps engineer. Junior DevOps engineer is quite new. Now, when junior DevOps engineer gets assigned with a task, maybe the junior engineer might write the wrong code on the local machine and execute that wrong code on the AWS. Although there is a senior engineer, but the code or the Terraform change did not go through a review. How can this be involved? This can be involved if you employ this approach, where the junior DevOps engineer clones the repo, makes the changes locally, push the changes back to the GitHub repository through a pull request. And then the senior engineer reviews the Terraform code. Only if the senior engineer is convinced and only when the CI check is succeeded. Of course, once the senior engineer is convinced, senior engineer asks CI check to run, and once the CI check is run, the CI creates the infrastructure on AWS. So you can follow this approach. Or what you can also do, once the pull request is reviewed and merged, then on the push action, you can run the CI. Now, once the commit is pushed, CI executes AWS infrastructure. You can also follow this approach. Additionally, now, when you use version control systems like Git, you also get backup, or you also get previous version of your Terraform script. What is the advantage here? What is the advantage of having your Terraform scripts version? Let's say even if you push a wrong infrastructure to AWS, your production might break, but instantly you can revert the commit because everything is in Git. Just revert the commit. Again, the revert pull request is also merged, and then CI executes and creates old version of the infrastructure on the AWS. So reverting the infrastructure also becomes simple when you integrate your Terraform code with Git. Finally, there is also proper auditing in this case. If you want to know 6 months before who made changes to a particular TF file, if everyone is doing it on local, there is absolutely no way you would know who created a resource on AWS and who updated a particular resource on AWS. Let's say 6 months before, someone created an EC2 instance. 4 months before, someone updated the EC2 instance. In the manual action way, there is no way you can understand it. But if changes goes through CI/CD, you will definitely know who made the changes 4 months ago and who created the EC2 instance 6 months ago. So overall, what I am trying to tell you here, Terraform files should also be in the Git repository. And who should execute the Terraform files? It should be CI systems like GitHub Actions. Your Terraform resources should be created on the cloud provider only through the CI. Now the question is, how do you provide credentials to your CI? Right? So if it is your local machine, you provide the credentials of your personal user. Right? If I am working on a hobby project, I will provide my AWS credentials. If my colleague is working on a personal project, my colleague will provide their own AWS credentials when working with the hobby project. Now, within the organization, everyone is running GitHub Actions. So, whose user would you provide, or whose credentials would you provide? So you need a common credentials. As I told you, we want GitHub Actions to be a single entity that is creating the infra on the cloud. So this single entity should have a single credential. Now you might say, okay, Abhishek, I will create a service account, right? I'll create a bot-like account. And for this bot-like account on AWS, I will create AWS credentials. Absolutely point on. You should do this. You should create a service account, basically like a dummy user. And for the dummy user, you should generate AWS credentials and you should provide CI with AWS credentials. But the problem is that a lot of people in your organization would have access to the CI. Let's say you wrote the GitHub workflow, a GitHub action that creates resources on AWS. And for this actions file, the common way to grant permissions, where would you store AWS credentials? You can say, Abhishek, I'll go to settings. In the settings, I'll go to secrets and variables. I'll go to actions. And here, I will provide the repository secrets. So I'll store my AWS secret access key, something like this. AWS secret access key and AWS access key ID. And within my CI file, I would reference the credentials. This is also good, but this is not completely secure. Now, I'm not denying this approach, but this approach is not 100% secure. You should ask why. The reason is that, understand this carefully. When you are working in a startup, it's okay. But if you are working in an MNC, you have thousands of users in the MNC. Even within a DevOps team, you might have 50 DevOps engineers. You might have 20 to 30 people in your management who has access to the repo. You might have some 5 developers who has access to the repo. Maybe senior developers who has access to the repo. Now, if you create a bot account, the service account on the AWS, and if you create AWS credentials for this bot account, and if you add these credentials to the GitHub, that is, if you add the credentials here, what if one of these people left the organization, but they looked at the credentials in the past and they want to use the credentials for bad purpose, or they leak the credentials to a bad actor. Now, most of the security threats happen through internal resources as well. It doesn't have to be they left the organization. They can still be in the organization. These 100 people or 80 people who has access to this repo, they can look at the AWS credentials that are being used in the CI and they can share these credentials to someone external in the organization. Now, because these are bot credentials, that is, because these credentials are from a central user like a service account, you would not really know who leaked the credentials. For example, if Abhishek's AWS credentials are leaked, Abhishek is responsible. But if bot's credentials are leaked, whom will you hold the responsible? 85 people has access to these bot credentials. One of these 85 people, they looked at the GitHub repo and they leaked the credentials to the bad actor. So again, there is no accountability here. That's why you need a strong secrets management solution. The problem that we are dealing with here is basically the long-lived credentials. What do we call this problem? This problem is long-lived credentials. You create a service account or a bot account. You create credentials for it on the AWS account and you put the credentials in the GitHub repo and they stay for ever and ever. For 3 months, 6 months, 1 year, most of the teams, they don't rotate the secrets. Even if they rotate once in 3 months, still you are at a risk period of 3 months. Within these 3 months, someone can leak the information. So what you need instead, you need a secrets management solution that can provide you with short-lived credentials. And these credentials should only live for 10 minutes, 15 minutes, till the time your CI executes, right? Now, what happens when you introduce a secrets management solution like HashiCorp Vault? Let's look at the workflow. Understand this workflow carefully. Now, in this workflow, which is typically a production-like workflow, Terraform resources are stored to the Git repository. All the Terraform resources are in the Git repository. Let's say one of the DevOps engineer clones this repo, makes the changes, that is, makes the update, and push the changes back to the Git repo. Now, on the Git repo, GitHub Actions is triggered. Right? GitHub Actions, what it does not have the credential. It would go to HashiCorp Vault and it would request the HashiCorp Vault, hey, I am running a Terraform script to create resources on AWS, but I don't have the credentials of AWS. Can you provide me with a short-lived credential? That is, can you give me AWS credential that lives for 5 minutes or at the most 10 minutes? You can design this according to your GitHub action execution time. Let's say your GitHub action executes for 10 minutes. GitHub action requests HashiCorp Vault to give short-lived credentials that lives for 15 minutes. So GitHub Actions takes this short-lived credentials, execute the resources on AWS, and after the 15 minutes, even if someone gets hold of these credentials, they are dead. That is, they don't work. That's the advantage of HashiCorp Vault. A lot of people think it is needed to store the credentials. No, you can store the credentials here as well. If storing credentials is problem, you have a lot of places that you can store. Best example, you can store it in the GitHub repository settings. But that's not the problem what HashiCorp Vault is majorly solving. The problem that it majorly solves is with long-lived credentials. So it will eliminate the long-lived credentials and it will generate short-lived credentials for 10 to 15 minutes for the CI/CD systems. CI systems take it and they execute the resources on the cloud provider using the credentials. And this concept is very, very interesting. Of course, I don't want to go too detail in it because it involves concept like OIDC, lot of networking concept and secrets related concept. But still, just to give you a simple picture, what GitHub Actions does here. So GitHub Actions, it uses the OIDC and requests the Vault. Now, Vault is pre-configured by DevOps engineer. So a DevOps engineer, a senior DevOps engineer, whoever sets up Vault, they initially provide Vault with the AWS credentials. Vault uses this AWS credentials and creates an IAM user. That IAM user is short-lived. Now, GitHub Actions just gets these short-lived credentials through the OIDC protocol. And for this, you need to do one-time setup, right? So you have to install Vault on a EC2 instance, or you have to install Vault on maybe Kubernetes, and you have to configure the Vault. That's what we are going to do at this point. But two things that you have to remember here, this is very important for your interviews. One, if someone asks you, what is HashiCorp Vault? Just don't say it's a secrets management solution. You should elaborate it. It's not just a secrets management for storing the secrets, but it solves a major problem with the life of the credentials. On top of that, you should also explain them Just in a one-liner, GitHub Actions uses the OIDC to interact with HashiCorp Vault and get temporary credentials. Perfect. Now that we learned about it, now that we understood the underlying concept as well, let's go ahead and create this setup. First thing that I'll do, I'll go to my AWS account. I'll create an EC2 instance here. All the commands that I'm going to execute, including EC2 instance creation and setup, are within the document that I prepared. Okay, I'll just call it as Vault Server, Ubuntu. Go with the free tier instance as itself. You don't need an instance that lives for, or you don't need an instance with more resources. A free tier instance is good enough. I'll use my PEM file. Okay, I need a security group. I'll create that later. For now, I will launch the instance. Okay, I use the default options. I used Ubuntu. I used free tier and I created the instance. Let's connect to this instance. Okay, so this is a public IP. I'll just copy it, and on my local machine, I'll just use the SSH protocol. Okay, SSH-I. I have the PEM file in my downloads folder. Downloads, Abhishek.Veeramalla.pem. This is the PEM file. And here, Ubuntu at IP address. Perfect. So I have my local connected to the EC2 instance. Whenever you work on a new virtual machine, always make an habit to update the repositories. We are using Ubuntu, so I'll update the apt repositories. Perfect. Then just install basic utility. We will use unzip here. Now why I'm using unzip, you will understand that in the next commands. But for now, let me install unzip utility. Okay, clear the screen, unzip. Okay, I installed unzip as well as wget. Now using wget that I just installed, I will download the Vault package. The Vault package is downloaded as a zip. That's why I will use the unzip utility. Perfect. Now I have the Vault folder on my local machine. Just move the Vault binary to user local bin. So we are moving it to an executable location. Now just run Vault version to verify the Vault server, the Vault utility executable is installed. There you go. The version of the Vault is 1.15.5. Now using the same executable, just run the Vault server. Very simple. Run this command, Vault server in the development mode, followed by on the address on which you want the Vault server to be listening. We will use localhost followed by port 8200. There you go. So we have the Vault server running on this terminal. We will keep this intact and on the other terminal. So I'll just duplicate this session. I'll reconnect to my EC2 instance, and here I will continue with the next steps. Till now, I just downloaded the Vault utility, the binary, and I started the Vault server. Of course, the server is started on 8200 port, so we need to open the port as well. Let's quickly do that. Inbound traffic rules. This is the one. Here we will edit the configuration, the security group, edit inbound traffic, and we can just add the custom port 8200. Or you can just open the traffic because we are just doing a demo. But in real time, don't open the entire traffic. Save the rules. Perfect. Let's access HashiCorp Vault. So we will take the instance IP one more time. This is the instance IP. And here, colon 8200. You can access the Vault server. If you want the token, go back to your instance or using this root token, just connect it here. Token, sign in. Perfect. So I use the root token, which is root in my case, and entered it in the root token section. And this is my HashiCorp console. So we have the Vault server running. Let's run, on the other terminal, let's log into the root. So I exported the address and I logged into the root. Perfect. Now we will run this command, vault secret enable AWS. Right? We are storing AWS secrets. So you can see here in the secret engines, you have AWS secret engine. Now here, as I told you, we will store our AWS access key as well as secret access key ID. How do we do that? We will use the terminal itself instead of creating it from here. So this is the command, vault write AWS configuration. And here you need to provide your secret access key ID and AWS access key ID. We will generate it. Go back to AWS, security credentials, and here scroll down, create access key. Right after this demo, I'll delete it. So there is no problem with security. Copy, paste it in the access key ID section. And secret key, paste it from the terminal as well. The AWS console as well. Perfect. Data written to AWS config root. In my case, I am using the AWS root user. But let's say if you're going with a normal AWS IAM role, in this case, I'm using the root user. So by default, it has all the permissions. But let's say to this AWS credentials, if you want to add some permission, whoever is the IAM user for this AWS credentials, if you want to grant them additional permissions, you can use this command. In our case, we are basically about to create an S3 bucket through the CI/CD pipeline. So I am adding S3 full access to this IAM role or the IAM user. As I told you, if you are using the root user, you don't need to do that. But most of the cases, you will not be granted with root user in your organization. So the AWS credentials that you are using should be from an IAM user with normal permissions. Whichever permissions you want to add permissions using this vault write command. Cool. So we granted this permissions as well. Now let's enable the OIDC on this server. So we will enable vault auth enable JWT, that is Java Web Token. Abhishek, why are we enabling this authentication? Simple. We want this vault to be accessed by GitHub Actions. So for GitHub Actions, to access the vault and to request for the credentials, you need to enable an authentication method. In our case, we are going to use, GitHub Actions will use JWT, Java Web Token. This is default. You cannot change it. Cool. In the next step, you enable JWT, but you have to provide the OIDC configuration that GitHub is going to use. This is provided in GitHub documentation. So you have to run this command to enable GitHub Actions for the OIDC configuration. Perfect. So now we enabled Java Web Tokens and we enabled OIDC discovery URL for GitHub Actions. Perfect. Now let's create the policy. So vault policy, write a simple Terraform policy. And finally, we will bind this policy to the GitHub repository. Okay, what is the policy that we created? We created the read policy, and now we will grant this read policy to our GitHub repository. In my case, the GitHub repository is I am Veeramalla DevSecOps Zero to Hero. Now this repository will get the read access, and through the read access and through JWT, Java Web Tokens, it will make a request to the Vault server, and Vault server will return it with the temporary credentials. Perfect. If you see here, token time is 1 hour. If you want, you can change this to 10 minutes as well. It's up to you. Perfect. Now we have the GitHub actions all set. Let's go to our Terraform folder. We will focus on the execution now. So we will go to the GitHub repository where I created a Terraform folder. In this Terraform folder, I will use S3 bucket configuration. Okay, provider AWS US East 1. I'm generating a random ID and I am creating an S3 bucket with name DevSecOps Vault demo followed by this random ID so that S3 bucket name is always unique. Now this Terraform configuration should be picked up by the GitHub actions, and GitHub actions should create this S3 bucket on the AWS. For that, we need to create a GitHub action CI/CD. I'll go to .github workflows, and here I will add a file. Let me just call it as ci.yaml or infracreate.yml. And I will write the simple GitHub actions here. I'll paste it here for your reference and I will explain this GitHub actions. What are we doing? Terraform deployment. On which action? On the push action. Every time there is a commit to this repo, the GitHub action should execute. But what should execute? We will use the Ubuntu runner. We will switch to the Terraform directory and we will just execute the Terraform init, the Terraform plan and Terraform approve. Only thing that you need to modify in this CI file, because it is very straightforward. We are using a GitHub runner. We are switching to the Terraform directory and we are running Terraform init plan and apply. But what's in between here is the most critical part. Fetch keys from Vault. So you need to provide the Vault IP address. In my case, the Vault IP address, I'll just copy it. You can make it a variable so that you don't have to update it manually. This is the Vault IP address and that's the only thing that I have to change. So now this GitHub action will make request to this Vault IP address. It will get the AWS credentials and using this AWS credentials, it will run Terraform init, plan and apply. The interesting part that I talked about, GitHub actions will not get access to our Vault AWS credentials, the one that we gave to Vault, but I told you Vault will create a temporary user on the AWS account. Let's watch that. Now, before I commit this file and before the CI gets execute, let's actually go to the AWS account. Let's go to IAM users and see if a temporary user is being created. We'll go to the users. Okay, right now we have 4 temporary users, which I executed in the morning just for the test purpose. Now, during this execution, this should change to 5. Okay, we will commit this file. Commit. Let's see what happens. Now the workflow should get executed. On the parent repo, we'll click on the workflow. Okay, it is running. Let's say what's happening. Okay, it actually fetched the credentials from HashiCorp Vault already. So a user should be created. We are here, still 4 users. If I refresh, it should be 5. There you go. And the lifespan of this user, the one that is newly created, is only for 10 minutes. Even if someone hacks it, there is no problem. Let's go back. The CI execution is complete. It said Terraform init is done, Terraform plan is done, Terraform apply is also done. Let's verify. We'll go to our AWS account again, but this time I will look at S3. Okay. On the S3, let's see if a bucket is created. General purpose buckets, and we have DevSecOps Vault demo. So this is just created. We have other buckets as well. As I told you, I used it for the demo purpose. But every time you run this CI file, a new bucket is created. Because in our Terraform script, we are asking it to create a bucket. This is how things work in real time. What is the major advantage of HashiCorp Vault? I'm repeating this again, I know, but it's very important for your interviews to explain. HashiCorp Vault provides a short-lived credentials, and this short-lived credential can be used in the GitHub Actions. How GitHub Actions is using them? It gets the credentials using OIDC and Java Web Tokens. Now, if you're worrying about the configuration that we executed, the commands that we executed, don't worry. Even I will not remember those commands. Everything that you have here, the vault.md file, I have taken from official documentation. I have collected it from different sources. So even if you're doing it in your organization in real time, you will not remember these commands. You will only get it from your documentation. So don't worry about the commands. Focus on the concept. Run every step in the vault.md by yourself. Understand what every command is doing. Finally, understand how Terraform works with Vault. This is the demo for today. I hope you liked basic security practices, Checkov, and also Vault integration. If you have any questions, do let me know in the comment section. See you all in the next video. Take care.